Assalamualaikum dan salam sejahtera. Hi guys. See you again in new chapter, which is chapter 3, Electrochemistry. Now, we are going to learn about subtopic 3.2, Nerst equation. So, this equation will relate with galvanic cell. So, guys, let's start. Now we look at Nerst equation. So this is Nerst equation. So this equation is used to calculate cell potential under any condition. It means that this Nerst equation can be used to calculate the cell potential for any chosen concentration. Before this, you dah lihat how to calculate E0 cell. E0 cell stand for standard cell potential, and the formula is E0 cathode minus E0 anode. But now you are going to learn how to calculate cell potential under any condition. So here R represent the universal gas constant, while N is number of mole of electron transferred in balancing redox equation, Q reaction quotient, T absolute temperature, F is Faraday constant. Okay, so later I will teach you how to calculate by using Nerst equation. How to solve the question that involve Nerst equation after this. Okay. But guys, normally the formula that we are going to use is this formula. The second formula, which is E in cell, which is cell potential, equal to E0 cell minus 0.0592 volt divided by N log Q. Okay, so what is Q? Actually, Q you dah pernah jumpa kelas masa semester lepas in chapter 6, reaction quotient, which is the concentration of product power of X. So this one will depends on the balancing equation divided by concentration of reactant power of Y. Now this one also depends on the coefficient in the balancing equation. So later I will teach you how to use this formula. But normally the second formula we are going to use if the reaction involved at 25 degrees Celsius, which is at 298 Kelvin. But normally in the question, most of the reaction will involve at 25 degrees Celsius. Okay, so this is the important part in Nerst equation because some of the question will ask you about the explanation. How? Like this. Okay, some of the question will ask you how to increase the cell potential. Macam mana you nak explain? Okay, so by using Nerst equation, sebenarnya you boleh tahu how to increase the E cell. Ada beberapa faktor yang awak boleh sentuh dekat situ. Okay, dekat sini saya bagi you all tips lah. Okay, so the first tips adalah cara kita nak increase E cell dengan we increase the concentration of reactant. So if the concentration of reactant increase, the cell potential also increase. Number 2, if we increase the concentration of product, not increase, if we decrease the concentration of product, so it will also increase the cell potential. And the last one, you can use this factor if we decrease the temperature, so the cell potential will increase. So ini adalah beberapa tips yang awak boleh guna untuk you jawab soalan jika dia tanya how to increase the cell potential of the reaction. Now we look at the spontaneity of cell reaction. Okay, this one after you calculate the value of cell potential. Okay, if you get the value of cell potential equal to 0, it means that that reaction occur at equilibrium. If you calculate the value of cell potential and you get positive value, so this reaction adalah spontaneous reaction. And if you got the value of cell potential negative, it means that this reaction is non-spontaneous reaction. So ini yang you kena ingat, okay? Okay guys, now we look at the calculation part, how we want to apply the Nerst equation in this question. Okay, so what we need to do first, macam biasa kelas, tolong keluarkan maklumat. Okay, maklumat apa yang penting. Okay, first info, you are very lucky here because you have the overall equation here. So yang ini adalah overall equation for this reaction, okay, and then we have the value of E0 cell here. So you dah tak perlu kira lagi the value of E0 cell. Kalau dia tak bagi E0 cell, biasanya dia akan bagi value of E0 cathode or E0 anode. So you can calculate the value of E0 cell. And then the question asks you to find the cell potential. Kita nak cari E cell. If the concentration of nickel 2 plus is 5 molar and the concentration of zinc 2 plus is 0.05 molar. And the second question asks you, will the following reaction occur spontaneously? So we have two questions here actually. Hati-hati, tengok betul-betul soalan. So kita ada dua soalan dalam satu soalan. Okay. So apa yang you kena buat? Pertama sekali yang you kena buat adalah you need to write the half cell equation. Memang dia dah bagi you overall equation, tetapi you kena juga buat half equation. Sebab apa? Sebab you are going to use this formula. Nampak? Tadi saya kata formula ni untuk 25 degree Celsius je. Tapi you kena faham sebab biasanya reaction memang berlaku dekat standard temperature. Okay? So, kita memang direct guna formula ni. Except kalau dia bagi temperature lain. So, dalam case ni temperature dia tak beri. So, we assume that this reaction will occur at standard temperature, which is 25 degree Celsius. Okay guys, why we need to write the half cell equation? Because we want to know the value of N. Ini yang kita nak tahu kelas. Sebab tu you kena buat half cell equation for anode and cathode. Okay, terpulang sama ada awak nak tulis anode atau cathode ataupun nak tulis reduction oxidation pun boleh. Sebab kita tahu at anode will occur oxidation process while at cathode will occur reduction process. So sama je lah. Okay, so based on the overall equation, we know that zinc will occur oxidation process. Sebab daripada zinc solid change to zinc 2 plus. So the oxidation number increase. So zinc akan jadi anode di mana dia berlaku oxidation. So awak buat equation dia, zinc solid produce Zn2 plus aqueous plus electron, 2 electron. Okay, sebab dia berlaku oxidation. So dia akan donate elektron dia lah. Okay, kemudian reduction berlaku dekat cathode. So kalau zinc adalah anode, of course lah nickel should be our cathode. So cathode reduction nickel 2 plus aqueous. So reduction normally dia akan accept elektron kat sini. Okay, so dia akan jadi nickel solid. So this is what we want class. So the number of electron here same, 2 electron. So bila you cancel out this electron, baru you dapat overall equation which is zinc solid plus nickel 2 plus aqueous produce zinc 2 plus aqueous plus nickel solid. Okay, so we already know that the number of electron needed here adalah 2 electron. Baru you boleh tahu N dia berapa. 2 electron. Nampak? Okay, so sebab tu you kena buat half cell equation. Okay guys, next kita pergi kepada calculation of cell potential. So we are going to use Nerst equation. Okay, sebelum tu nak dapat markah formula awak mesti lengkap, mesti gantikan what is Q. You need to mention what is Q. Kalau you hanya tulis macam yang saya buat tu, you tak dapat markah formula ya kelas. Okay, so macam mana nak dapat markah formula? So E cell equal to E not cell minus 0.0592 divide by, nak terus divide by 2 boleh atau nak tulis N dulu pun boleh. So dekat sini saya buat N dululah. Log Q. Tadi madam kata Q tu adalah reaction quotient, di mana product divide by reactant. So kelas, tengok dalam kita punya overall equation. Okay, so overall equation kita, produk kita adalah zinc 2 plus dengan nickel solid. Okay, if you still remember, in Q, formula Q yang kita ambil kira adalah aqueous atau gas phase. Saya repeat, yang kita ambil kira adalah aqueous atau gas phase. So solid and liquid phase will not involve in reaction quotient. Kita apply concept chapter 6 last semester. So here for the product side, so yang akan terlibat adalah zinc 2 plus aqueous. So dia punya coefficient adalah 1 mole. So dia akan jadi Zn 2 plus power of 1 divide by concentration of nickel 2 plus power of 1 also. So zinc solid will not involve here. Why? Because solid phase kan, tidak akan terlibat dekat sini. And then you can substitute all the value here. So E naught cell we have 0.51 volt minus 0.0592 divide by 2 log, ini keseluruhan ya. Zn2 plus punya concentration adalah 0.050 molar divide by 5.0 molar. Okay, so this is your substitution value, and then you will get the answer is positive 0.57 volt. Jangan lupa final answer must insist unit. Okay, so volt, unit of cell potential and standard cell potential is volt. Okay, so we already answered the first question, the value of cell potential here. And the second question asks you, will the following reaction occur spontaneously? So we got the positive value. It means that yes. So E naught cell more than 0. So the reaction is spontaneous. Okay, attention please. You need to know this part. At equilibrium, no net reaction will occur class. So reaction quotient, which is Q, must equal to K, which is K, we know that one is equilibrium constant. Ingat lagi masa chapter 6 ada relate sikit lah dekat sini. Okay, so E cell will equal to 0. E cell means yang tadilah cell potential. Okay, so kita tak akan guna formula ni. Kan, sebab apa? Sebab E cell will equal to 0. So we are going to modify this equation. This formula become this formula. So kalau soalan itu melibatkan at equilibrium, so you are going to use this formula. Okay, directly use that formula. Now we look at the example. The question asks you to calculate K for zinc and copper cell. So here you are given the value of E0 cell for the zinc and copper. So macam ni lah kelas soalan exam. So sebab apa? Dalam exam memang dia tak akan beri you all table standard reduction potential. So dia akan terus bagi nilai standard reduction potential for each metal ataupun for each cell dalam soalan macam ni. Okay? So, based on the value of standard cell potential for each metal here, you need to predict which one is our anode and which one is our cathode. Awak kena tentukan dulu mana anode, mana cathode. Saya dah ajar dalam chapter subtopic 3.1. So, as we know that class, if the value of E node more positive, dia akan jadi cathode. So our cathode should be copper. Okay. And we know that if the value of E node more negative, so dia akan jadi anode. So kita dah identify our anode and our cathode. So what you need to do first, you need to write the half cell equation and overall equation first. Okay, tu yang kena buat dulu. Apa-apa pun equation wajib buat dulu. Okay, so jom kita buat dulu. So kita buat untuk anode dulu. So kita dah tahu anode adalah zinc tadi. Okay, so awak terus je buat equation. Kita tahu anode akan undergo oxidation reaction. So here zinc solid will undergo oxidation, become zinc 2 plus aqueous plus 2 electron. Okay, so equation ni sepatutnya you all dah mahir buat lah. Okay, bila ion biasanya dia punya phase adalah aqueous. Okay, and then for cathode kita ada copper. So copper will undergo reduction. So Cu2 plus aqueous will accept 2 electron, become copper solid. Okay. So and then kita boleh buat dia punya overall equation by cancel out the number of electron here. So you will get zinc solid plus Cu2 plus aqueous produce, okay, zinc 2 plus aqueous plus Cu solid. So this is your overall equation. Okay, and then kita guna terus formula. Formula yang tadi kelas. Formula yang berkaitan dengan equilibrium. Okay, which is the formula is E0 cell equal to 0.0592 divided by N log K. So you can directly use this formula. Okay, E0 cell ada tak diberi dalam soalan? Tak ada kelas. So macam mana nak kira E0 cell? Kita ada formula dalam chapter 3.1 kan, iaitu E0 cathode minus E0 anode. So kita ada cathode positive 0.34 volt minus with negative 0.76 volt. So you will get the answer is positive 1.10 volt. So this is the value of E0 cell. And then you dah dapat, you dah boleh kira K lah. So E0 cell kita positive 1.10 volt equal to 0.0592 divide by 2 our N. Ingat N tu adalah nilai electron, number of electron that we cancel out from the half cell equation. So log K. So and then press your calculator, you akan dapat the value of K equal to 1.45 times 10 power of 37. So no unit for equilibrium constant. Okay, so ingat bila melibatkan K, we know that E cell must equal to 0. Alright. Okay guys, that's all for subtopic 3.2 Nerst equation. Later I will see you in subtopic 3.3. Bye guys. Thank you.